447. Okay. Now what is the first step you want to do this problem? I think a lot of people are just change into improper fraction, right? Yeah, we can do this. You change this into improper fraction, right? You can do this, right? But this is not the efficient way. Let me tell you of efficient way, okay? Most of people just change this into improper, mixed number, change it into improper fraction. Now, we can take a look here. We have a 5, right? Can we change into something like this? Yes or no? Can we change a 5 into something like this? Yes or no? Can we change a 5 as a 4 and what? 4 and what? 7 and 7, yes. Right? If the kids understand the concept, 5 is equal like this, they can do this efficiently, right? Now next, what's next? Can we take a whole number minus whole number? Yes or no? Now once we take whole number minus whole number, which is 2, is that right? Can we take a fraction minus fraction, yes or no? So 7 minus 4, I got 3. And that's the answer. Then you don't have to change it back again, right? Actually, I have seen one of students doing this. This is a great thinking, because this is from the conceptual understanding, And then if you just change it into improper, that's fine. But here review, I like to share with some efficient people. Good, oh, this is good. I want to share with you, right? Instead, I will give you, the traditional way, right? Any questions for this? 21. No. About 22. Problem 22. Give the name. Give the name and give a number. 150 and 200. That is divisible by 7. All right. Now, give a number. That is between a number between 150 and 200. So we want to find out a number between 150 to 200. Give a one number and then divisible by 7, right? What did you do this problem? You just pick up any random number and just divide by 7? Yes or no? Yeah, and I think so. Most of people are doing this way. This is not efficient. This method is work, right? But it's good for what? Good for the number like this is small number. If I give you 1,000, you get 2,000, right? Sometimes it's not easy to find, right? Yeah. Do we have a way? Yes, we do have a way. Let me show you, okay? If you take a 150 divided by 7, okay, let's take a look. And what? You fill in the number, this is how many? 2, right? And this is a 14, right? And then 0 bringing down, that's a 1. Is that right? So what's the next number we have to fill in this? Fill in 1, right? 7 times 1, we got 7. And then we got 3. And this is not a divisible, right? 150 is not divisible, right? And what does this tell you? You divide it by 7 and you have a 3 left over, right? Remainder, right? What does this tell you? How can we make this is divisible? If we add how many more? We add how many more we can make it divisible? You have 3 left over, right? You add how many more you can make divisible? Yeah, if you add 4, and this will make you 154, and divisible, right? And then how many more? 4 more, right? Are you with me for this concept? You add 4 more, and you make it divisible. Do you believe it? Yes, that's right. 7 and then 1 and 14, and then bring down 44, and then make it 14. That be, 2. Oh, 14, and we got a 0. Did you see it? You add 4 more, right?
It's supposed to be 22.
Oh, I'm sorry. That'd be 14.
7 goes up 15 2 times.
Instead of 12, 22.
22? Oh, 22. Sorry. Right here, okay? Yeah. Thank you for calling my mistake. All right. So, is it divisible? Yes. This is divisible, right? Once we add 4 more, and then we find it divisible, right? And next time, if you guys give a number is 1,000, can you find it out easy? Yes. You just divide and find out how many more. Does that make sense? Number 23. Number 23. Seven A equal 56 question mark, right? And basically, can we just do and cross multiply, right? And we can find it out. X will be equal 64, right? Yeah, we'll cross multiply. Or one way we can do it just cross multiply, right? What's the other way we can do? What's the other way we can do? 56 actually is 7 times how many? Times 8. Is that right? Alright. So now, on the bottom here, we can make it as like equivalent, right? So therefore, should we fill in 8 times 8, yes or no? And then we got a 64, right? It's another way of thinking, right? So therefore, we say x, okay, x will be equal 64, right? Any questions? Okay, and this is what? Equivalent fraction, right? Proportional reason, right? Proportional. 2 ratio, they are the same fraction, so therefore, this is a proportion, okay? Number 24. Number 24. 9.5 divided by 0.5. All right. So 9.5 divided by 0.5, right? Now in the past, probably the teacher will tell you, right? You have to move the decimal point, right? So we want to move the decimal point, I guess. But yesterday we talked about why we have to move the decimal point when we do the multiplication, right? Now today I'm going to tell you why we have to move the decimal point when we do the division. All right? Nothing is a mystery, okay? It must have a reason. Must have a reason. So you move the decimal point over here to the left, to the right. To the right, right? For 1, right? And then therefore, you must move this at the same time. Is that right? Okay. Then therefore, in the past, probably teacher will ask you, just walk on here, walk on here, and you can say, oh, this is a 5, 9 divided by 5, you got a 1 and 5, and then minus this, and then, 5 bring down, and then a 4, and you got a 19, right? This is 19, and therefore, where's the decimal point? The decimal point, student will put up right here, correct or wrong? Wrong. It's a misconception, right? The decimal point, since you move over here, the decimal point is right there, right? Then, do you think that this is a good instruction? I don't think that this is a good instruction. This is horrible instruction, confusing instruction. What is better? The better way to do it, you not ask student work on something that is right here, okay? You can ask the student move the decimal point, that's okay. That's okay. Alright? The best way to do it is sometimes if you insist on doing this, you can find a lot of mistakes. Student always a wrong place value. Alright? What is a better way to do it? Yes, we have better way to do it. You move the decimal point, that's right. And then you have to move the decimal point for this one at the same time, right? Start a new one. That means what? 95 divided by 5. Just get a start new one. The kids won't confuse where's the decimal point right after. Right? Does that make sense to you? So now we can work on here because you move like this and move like this, and pretty much 95 divided by 5, right? And then actually is 1, 5, alright? And then this is moving down 5 and 45. And therefore, students so happy they got a 19 instead of 1.9. Right? Start a new one, okay? This is what I would suggest. And if you teach this way, every single time student get right answer. If you insist to do it in the traditional way, student always struggle with the, where is the place value, where is the decimal point. Does that make sense? Okay. So we're taking care of the procedure, right? But an important thing I need to tell you, what is the conceptual understanding of this? This is most important. But most of you did not taught a way like this, right? But I wish you, in the future, you teach your children, learn and what's going on, right? So now, what does the meaning for this? So again, we have to connect to what? Connect to what's the previous knowledge, right? When we say 9.5 divided by 0.5 actually is what? Fraction. Tell me what's the fraction mean? 9, 5, 10. Is that right? And then divided by what? Divided by 5, 10. Alright? Now, look. Can we say 95 divided by 10, like this? And then divided by 5, 10, yes or no? Alright? And actually, here's this. Alright? Traditional way is just have you to flip over, right? Times, right? Now what about this algorithm? This algorithm is correct. But rarely you can see the school, the teacher know how to teach this, okay? Take a look. I'm gonna highlight this with a different color. That helps you to see. $95 divided by 5 over 10 divided by 10. Alright? 10 divided by 10 actually is equal 1, right? So therefore, that's why we change this to 95 divided by 5. So therefore, we have 95 divided by 5. So therefore, 95 divided by 5, which is equal 19. Is that right? This is a correct algorithm. This is correct one. Alright? Now when we say move the decimal point to the right. What does this mean? We times how many? We times how many? Times 10. We times 10 here. Should we times 10 over here? And that's why we can make it equivalent. That's why. That's why we move here. We also have to move here at the same time. Does that make sense to you? Why? Because we times 10 there, and we times 10 there, right? Now we times 10 there, we make it as 95, we have divided by 10, right? And we have divided by 10, right? This is why. If you look at it as a fraction, you can see what's the picture there, right? So now this is a problem 24. Problem 25. You have 5 marbles in the bag. And they are number 1, 2, 3, 4, 5. And for you draw 1 marble from the bag, what is the probability of drawing a 2? So what is the probability of drawing a 2? So now 5 marbles, and you got a number 1, 2, 3, 4, and 5, right? Now the total chance is equal 5, right? What is the chance to get 2? 1. What's the chance to get 5? 1. What's the chance to get 1? 1. What's the chance to get 3? 1. Is that clear? Okay. 26. Problem 26, all right? 1, 7 times 3, 8. So we got to take a numerator times a numerator, denominator times a denominator, right? And then, therefore, it will be 3 out of 56. Final answer, yes or no? Yes. We cannot reduce anything. $27. All right, so this one, 27, yes, 27. 27, we have a lot of people make a mistake for this problem, all right? 27. Any questions? Is doing okay? Yeah. If I don't see any problem, I'll just move up, right? 27. Around 80% of people make a mistake for this problem, right? 80%, which is a lot. And then most of people have a problem with what? With the wording. Okay. Let's work together on this problem. 27, okay? If you pay $30 for a garment on sale for 40% off original price, what was the original price? Okay, please highlight 40% off. So 40% off, what does this mean? You pay how many? 40% off, what does this mean? This is original price. You pay 40% off. You actually pay how many? 60%. Did you get it? See, sometimes you get a coupon from Kohl's or Macy's or from the department store, right? They say 20% off. What does this mean? You pay 20%? No. Give you 40%. Table, okay? I'll show you the table. I will show you the table here. So, I'll show you the table here. Alright. I'm gonna feed in this. This is the money. Alright. Then I'm gonna show you. Oh no, sorry. This is a percentage. Alright. And then this is the money. Alright. Can we fill in this? 60% right here. Right? Now 60% is equal how many dollars? Is that right? 30. Then 100%, I don't know, right? This is 100%, is that right? Can we say X, yes or no? Okay, 60 out of 30 is equal 100 over X. Can we cross multiply? Yes or no? Alright, so cross multiply 60x, which is equal 3,000, is that right? Divided by 60, divided by 60, S is equal 50. Oh, $50. Now $50, you wanna see the answer makes sense or no? Right? The answer I got is $50. Now $50 is original price, right? Now you wanna take 40% off, right? You actually pay 60%. Now 60% is equal how many dollar? $30, right? Yes. Always double check, right? So this is another way you can do it. You like the table one, right? All right. Any questions so far? Number 28. Two and three fifths divided by 3 and 4 7. And this problem actually we have to change into what? Mixed number, change into a improper fraction, right? Change into improper fraction. Change into improper fraction. This is 5, this is 13. 2 times 5 plus 3. And then 7 times 3 plus 4, we got 25, right? Then, once we're taking care of the issue of divide, change into multiply, then we can do this, right? So therefore, we have 7 over 25. 13 times 7, 91. 5 times 25, 125. Is that clear? If no problem, I will just move on. If there's a lot of consecutive answer has to answer y, then I will spend more time on y, okay? Or if there is another different way I can show you, or better different way I can show you, right? And I will just review a different way, okay? 29. Write a decimal name for 5 out of 32. Actually is what? When we have changed into a fraction to decimal, right? One way we can do, we just do the long division. Long division can take care of everything, right? Another way is you want to look at numerator. Can numerator make it as a 10 or 1,000 and 100, something like that? 432? nothing we can make it this, right? But if we can make it like a 20, like for example, like this one, 5 out of 20, oh, yeah, good news. We can change this into 100, is that right? Right? And then therefore, we take a 5 times 5, 25. 25 out of 100, is that right? Unfortunately, this one, 32, nothing we can make it as nothing we can make it like hundreds and thousands and so on, right? The only way we can do is long division, right? Only way we can do it is just long division, right? So yes, this is the only way we can do. We cannot do the quicker way. The only way we can do is this. Okay, now this is kind of testing your division. Okay, 5 divided by 32. All right. This is also testing your understanding of the next place value, which is 50. But, all right, 5, next place value, okay, 50. So therefore, big one, 32. And what is the next one? 180. And moving on to the next place value, 180. We have a 5 times 32, 160. And then 20. And then move on to the next place value. 6, and then 192. All right, and with 80, next place value, lining up. 2 times 32 is 64. Next place value. Moving down. Oh, good news. We added out 5 times 32, 160, 0. Okay. This is a pretty much kind of, testing your understanding. Can you do the calculation, something like this, okay? Number 30. Change this into improper. How we do this? We take a 6 times 3 plus 1, right? So therefore, how many? 19, right? 19 over 3. 31. 3 times r plus 7 equals 30, right? This is pretty much the problem we can do for solve for x, right? Or you can do distribute property, right? You take a 3r times 3r plus 3 times r, 3 times 7, 21, which is equal to 30. And then 3r minus 21 minus 21, which is equal 30 minus 21, which is equal 9, right? And we divide it by how many? Divided by 3. And r is equal 9. Right? I don't think there's any problem with this, right?
Equal 3.
Oh, 9. This is 3. All right, now 31. Now 32. 32. 1/7 plus 2/5. All right, again, we have to change this into what? Common denominator, right? So this would be 35, and this will be 35. 5 times 7, 35, right? So we take a 5 times 1, 5. 7 times 2, 14. Add together, 19 out of 35. Final answer? 19 out of 35, final answer? Yes, this is the final answer. Nothing we can reduce.
Is that right? Okay, I guess I have a question.
Yes. What's your question?
When we multiply the fraction, like the 5
Mm-hmm.
to get the 35, don't we multiply it
Yeah, we
by
times
7?
we times
Oh.
5 times 7, 35,
7
5 times
times
1, 5.
Sorry, I was
7 times 5, 35, 7 times 2, 14. Take it together, 19, yes.
I was looking at when you pointed. My bad. Sorry.
So, conceptually understanding why we have to change into 35, right? And then, once we have a same common denominator, then we can add together, right? Okay. Now, 35, no, 33, 33 actually is integer operation. Negative times a negative equal or positive, right? So therefore, this is a positive 15. Alright. In your next class, 220, if I am teaching this, I will show you at least 8 different ways of exam to answer why a negative times a negative is equal to positive. Okay? But in 120, basically, we mostly working on the whole number operation, right? And then the next class we work on like decimal, more decimal, and fraction, and also, and integer operation, something like that. Okay. All right. This would take at least one day or 2 days class to explain to you why. Okay. Next, 34. Square root 169. All right. When we say square root, what does this mean? Why we don't say a triangle root? Why we don't say a circle root? Why we don't say a trapezoid root? Why we don't say rectangular root?
It's the number squared to get what your answer is what will be squared to equal 169.
Mm-hmm. Yeah. Has to be connect to square, right? So what does the meaning square root for this, right? Square root, right? And if I draw a picture like this, you will understand, okay? This is a square, all right? Perfect square, right? Now perfect square. Now square root basically is right here, right? Square root is right here, right? And where is the 169? 169 is right here, right? Now square root is looking for the length of this. And times itself another length, right? And that is meaning square root, okay? It has to be under the square, right? Now what 169, what does this mean? This means I have 169 little square here, 1 by 1, right? 169 like this, right? Now, we take a square root, that means how can I find what number can times what number for the lengths can times each other, right? Does that make sense? So, that's why we have to break it down 69 as what? 13 times 13, right? We know this is 13 times 13. Alright, 13 times 13, that means that this question mark is 13. We have 13 units for this, right? And the other side is 13, right? So therefore, is 13. Are you clear? Why we have to say square root, right? 35. Negative 18 minus 7, which is negative 18 minus a positive 7. Right? So therefore, which is negative 25. 36. Negative 5 plus 18, which is, you have a negative 5 plus 18, which is 13, right? 35, 36, 37. 89 minus 3 fourths. Again, addition and subtraction, we have to take care of what? Common denominator. So now this time, common denominator is a 36 for this, and the other one is 36. And then 4 times 9, 36. 4 times 8, 32. 9 times 4, 36. 9 times 3, 27. So therefore, you take a 32 minus 27, which is equal 5, right? 5 out of 36, final answer? Yes, final answer. If you're not good at a fraction operation, this is a time you can relearn, right? And this is a time you can bring your memory back. All right? And this is crucial. You gotta teach your children every single day of this. You know, I'm not kidding, it's true. You gotta teach them every single day like this. And you need to good at this, right? And not only procedurally, you need to have a knowledge of conceptual understanding, right? Now, LCM, problem 38. List the common multiple. Okay. Now list the common multiple of 9 and 12. And we have actually LCM. Right after the midterm, we will talk about this more. I will give you more method. But here, I'll just give you two methods, okay? One is a traditional way. The other, this is a traditional way. You break it down. This is a prime factorization, right? And I think most of students learn this way, right? Most of people learn this way. So 9 actually is 3 and 3. Is that right? So actually we have a 3 square. Okay? And then 12, actually we have a 3 and 4, right? And then 4 actually is 2 and 2, right? And then we will write this is 3 times 2 squared, right? This is a traditional way. This is the most US textbook they show this way, called prime factorization method, right? And then what is the LCM of this? They have a student, just finding out what's the prime number, find out what's the prime number, right? And next, write it down, all the prime number. So do we have a 2? Yes or no? Do we have a 3? Yes or no? Yes. But not 2 times 3. The next step is choose the greatest power. So 3 square and 3. Which one do we choose? We choose this one or choose one? We choose 3 square. And then this one have 2. This one have 2. So therefore choose 2 square. Alright, so this is 4 times 9, the answer will be 36. Most of US textbooks show this way. Very confusing. Can all the children memorize like this? I don't believe, right? Yeah. Do we have a better way for this? Yes, we do. Let me show you another way. This is a German classroom doing it, okay? The German classroom doing this way. You can compare. This is so much step. The German classroom is only one way, or only one step you can find in other ways, okay? This is a German classroom they will use, okay? So you take a 9 and 12, okay? Normally, we will start here with a prime number, okay? Now if we can divide, we divide. If not, we just put in down a number, okay? So here is 9 and 12. So both divisible by one number. What prime number? 3. So 9 divided by 3, we got 3, right? And next, 12 divided by 3, what we got? 4, all right? Then in the German classroom, they will check, prime not prime, right? So therefore, we have to do it again. Here we have prime, okay? So prime, not prime, we have to do one more time, right? And then now next, what is the prime number we can divisible by 4? 2. So I put on the 2 there, right? Now what about 3? Don't worry about 3. 3 just simply, if it's not divisible, just simply bring down that number. Alright, simply just bring it down that number. Now what about 4? 4 divided by 2, how many? It is 2. Now check. The next, check. 3, prime number. Yes, we all got prime number. So therefore, we got all prime number here. Then what should we do? We just times each other, all the prime number. So the LCM is 3 times 2 times 3 times 2, which is 36. Okay. We will talk about more for this method, for this method. And I think that we'll probably here for today. Okay. Then the rest of problem, if you look, the rest of problem is very similar.